Our section 1.3 in Trig is going to involve our trigonometric functions. Now, a lot of these are going to seem very familiar to you because you did learn these in geometry and also in Algebra 2. So a sine function, remember in geometry and in Algebra 2, I'm going to give you the old definition, was originally defined as the opposite over the hypotenuse. But today in Trig, when we look at a right triangle in the coordinate plane, we're going to refer to the horizontal and the vertical components as x and y, and then the hypotenuse we're now going to call r, and r is going to be defined, if you look down here in your notes, as the distance from the origin to whatever point we're referring to. So for sine, instead of opposite over hypotenuse, we're going to call it y over r, which you notice those are still the letters that are in the opposite and hypotenuse position. So cosine, we used to define cosine as adjacent over hypotenuse. So when I look at my triangle, cosine is now going to be defined as x over r. And then the tangent was opposite over adjacent. So if I look at my triangle, opposite over adjacent would now be y over x. Now our inverse trig functions, the cosecant, which we abbreviated as CSC, remember was the inverse of the sine function. So instead of sine, he was the reciprocal of it, hypotenuse over opposite. So instead of y over r, he's r over y. The secant is the reciprocal of our cosine. So it's hypotenuse over adjacent, or in our triangle's case, r over x. And then the cotangent was the reciprocal of our tangent. So he would be adjacent over opposite, or if I look at my triangle, x over y. And then just to refresh your memory, last lesson we talked about how to find the distance of any point from the origin, and that was to kind of think about distance formula with one of the points being 0, so r is going to be the square root of x squared plus y squared. Technically distance formula, but since one of the points is 0, it's kind of easy. So we're going to find the 6 trigonometric functions for a point, for theta, where the endpoint is at -2, 3. Now, I don't see a picture, and I really need a picture. So I'm going to draw myself a little picture. Oops, draw better than me. -2, and then 3 would be roughly right here. And the next thing I want you to do is draw yourself a right triangle. Whoops, that should be on the axis. So let's look at the things we know. The distance from on the horizontal part of this triangle is a distance of 2, but because he goes in the negative direction, I'm going to label it as a -2 for now. The vertical component is up 3, and then the r is the hypotenuse. That's what we're going to have to find. So technically, we'd be using our formula, which says x squared plus y squared. So I'm just going to use the positive versions of both x and y, which gives us 4 plus 9, so that's the square root of 13. So now I have all the information I need, and I can come up with my 6 trigonometric functions. Let's start with sine of theta, cosine of theta, and tangent of theta. So if we use our formulas, sine of theta would be originally 3 over square root of 13, but we don't like the radical on the bottom, so the ACT will often rationalize this, so we're going to do the same. We're going to multiply top and bottom by the square root of 13, and if you can do this in your head, you don't have to show the work. So it's going to be 3 square roots of 13 over 13. The cosine of theta, even though the side of the triangle is 2 units long, I'm going to keep the negative with the x value, so -2, and then over the hypotenuse, square root of 13. So again, we're going to rationalize the denominator. Eventually I'm going to stop showing this step and expect you just to do this in your head. So it's -2 square roots of 13 over 13. And then the tangent of theta should be 3 over -2, and there's no radical to rationalize, so we're done. Now, they want all 6 trigonometric functions, so we're going to have to go and take the reciprocal functions. So let's look at cosecant of theta, which we know is the reciprocal of sine. Go back to the original sine setup, 3 over square root of 13, and just take the reciprocal of that one. Because if you take the reciprocal of the one that's been rationalized, you're going to have to rationalize again to get out of it. Alright, then cosine's reciprocal is secant. And again, go back to the original. Doesn't matter where the negative ends up, whether it's in the numerator, the denominator, or just out in front. And then the reciprocal of our tangent, whoops, that's not what I meant to write. It's cotangent. And again, whoops, theta. It doesn't matter where you write the negative, so it's negative 2/3. So there's your 6 trigonometric functions for the point negative 2, 3. Okay, we're going to do the same thing now, except the clue they give me is that it's a 45-degree angle. So they don't tell you where the point is, and if you remember a few lessons back, when we thought about drawing a 45-degree angle, oops, and then dropping it down, it created a 45, 45, 90 triangle. And that meant that the vertical and horizontal components could be anything along this ray, but we knew that no matter where we landed on this ray, the x and the y value were going to be the same thing because the legs are congruent in an isosceles 45, 45, 90 triangle. So you can do any point you want. I'm just going to use the point 1, 1 because that looks like less work to me. So I'm going to say that this is the point 1, 1, and that's where it terminates. So the x and the y are both 1, and if we did some Pythagorean theorem, 1 squared plus 1 squared is 2, so it's the square root of 2 for the r, or for the hypotenuse. So again, we're going to set up our 6 trigonometric functions. Oh no, they only want 2 this time. They want sine and they want cosine. So sine of theta would be opposite over the hypotenuse, or y over r. So again, you're going to have to rationalize the denominator, and you end up with the square root of 2 over 2. And then if we look at cosine of theta, it would be the x over the r, or adjacent over hypotenuse, and oddly enough, he ends up being the same value. We're going to learn something called the unit circle. It's something that you briefly touched on in Algebra 2. And we're going to realize that whenever we have a 45-degree angle, or a relative of the 45-degree angle, your sine and cosine are actually going to be the same value. Sometimes one will be positive, one will be negative, but we'll come to that later. So, moving along. All 6 trigonometric functions for 270 degrees. All right. So if I think about my coordinate plane here, and I measure 270 degrees, that would be coming all the way down to the negative y-axis. And once again, the r value can really be anything you want. So I know a couple things about this point along this axis. I know for sure that the x-coordinate is 0, and then the y-coordinate is pretty much anything I want it to be. So what I'm going to do is I'm just going to again call it a 1, because 1s always provide me with a little less math to think about. But if you think about where you're at in the coordinate plane, it wouldn't be a positive 1, it would be a negative 1, because it's down 1 unit. So if I think about sine of theta, cosine of theta, and tangent of theta. Since we don't have an actual triangle, we can't use our opposite, adjacent, and hypotenuse theorems here. So we have to really think about what our r value is. And since I used the point 0, negative 1, if I calculated the r value, 0 squared plus, I'm just going to say positive 1 squared, we end up with an r value of 1. So basically what I have here, my x value is 0, my y value is a negative 1, and my r value is a 1. So using your new trigonometric function formulas, the sine is y over r, so the sine would be a negative 1 over 1, which we of course know is a 1. Cosine would be x over r, so 0 over 1, which we know is a 0. And then the tangent would be y over x, so negative 1 over 0. And remember, anytime we divide by a 0, we would get an undefined answer. So it turns out that the tangent at 270 degrees is actually an undefined value. Let's do our reciprocal functions now. Cosecant of theta, secant of theta, and cotangent of theta. So remember, this is called a quadrantial angle, and these 6 trig functions are actually kind of easy because you don't have to worry about radicals whenever you're on a quadrant axis. So the cosecant, go back to the original, would be the reciprocal. Well, it doesn't really matter what order we do this in, it's still going to come out to a negative 1. The secant, go back to the original cosine and flip them, would be a 1 over 0, which we see now. The secant is undefined. And if you go back to the original tangent and then flip them, you find out that the cotangent is now a 0. So kind of interesting. I think at first glance some of you probably thought the tangent and the cotangent would both be undefined because they're very closely related, but it actually turns out the tangent and the secant were undefined. When we talk about graphing trig functions later on, you're going to see how this looks in a trigonometric graph. Sine of theta is negative 5/13, and we're in quadrant 3. Find all the rest of the trig functions. So again, I really need a picture. So quadrant 3 would be down here, and I'm just gonna draw apparently a really ugly triangle. Since sine is negative 5/13, remember sine is the y over the r. Now since we have y and r, we can kind of go backwards. I'm gonna fix that a little bit to find the x value, and we're going to do that that's not much better, by doing Pythagorean theorem. So Pythagorean theorem, or that same formula in reverse, 13 squared equals negative 5 squared plus x squared. So let's see, that's 169. We're going to subtract the 25, and turns out this is a Pythagorean triple, which maybe you noticed right away, that the x value is going to be a distance of 12 units, but if you think about the coordinate plane, going left to get to that point means it's actually a negative 12. I'm going to label it that way so I have my correct signs for my trigonometric functions. So we already know sine of theta is negative 5/13. Now let's talk about cosine and tangent. Cosine, remember, is x over r, or adjacent over hypotenuse, so he's negative 12/13. And the tangent would be y over x, so negative 5 over negative 12 would be a positive 5/12. So my reciprocal functions, cosecant, secant, and cotangent, should be pretty easy because we don't have radicals to worry about. So he's a negative 13/5. Again, it doesn't matter where your negative goes. He's a negative 13/12. And then this is still positive 12/5. Okay, this table is telling you who's positive in what quadrants. And if you really thought about what the formulas were for sine, cosine, tangent, cosecant, secant, and cotangent, it would make a lot of sense. If you think about, in quadrant 1, both your x and y components are positive, and r is always positive. So that's why when you look at quadrant 1, all the 6 trig functions are positive in quadrant 1. So draw yourself a little coordinate plane, and I'm going to write down all of them are positive in quadrant 1. Now when you move to quadrant 2, think about the coordinate plane. Your x values are now negative, but your y values are still positive, and r is always positive. So it makes sense that only sine is going to be the positive trig function, or his relative, his reciprocal, cosecant. Here, I'll put theta. And that's because with the y and the r being positive, that's the only way you're going to come up with a positive fraction. Now in quadrant 3, the tangent and the cotangent are the only positive values. And then in quadrant 4, cosine and secant. Oops, positive. And again, it all has to do with who's positive in the actual coordinate plane. The x, the y, r is always positive, but it's going to affect the sign of your fraction. So we have a cute little mnemonic device for this. I'm going to draw another coordinate plane for you. And it says all students take calculus. And all literally represents all trig functions. Students, I want you to look at the S, and that's going to jog your memory that sine and his relative of cosecant are positive. Take, I want you to look at the T and realize I'm referring to the tangent and his relative, the cotangent. And then calculus, look at the C, and it's going to remind you that cosine and his relative secant are positive. You're going to have that memorized. Otherwise, you got to get creative and coming up with the answers every time. on your quiz, I believe I ask you to fill out a chart that looks like that. And I'm pretty sure there's a homework problem like that too. So a little bit of a review here. It's asking you about, where are we at? Whether the angles are coterminal. Let me move ahead a little bit. Let me just, so this worksheet, I believe, begins worksheet 1.3. I don't have the heading on it, so I'm a little confused. But this is going to be part of your homework assignment, and I'm just going to kind of walk you through maybe example here and there and make sure we're all on the same page. So when they want to know whether angles are coterminal, remember we find coterminal angles by adding or subtracting groups of 360. So 40 and 400, if you take a 40 and you add 360, you get a 400. So the answer here is yes, those are coterminal. Sometimes you have to add or subtract more than one group of 360, so be careful. On the next part of the homework, they're going to want you to draw the point. So in this case, we're at 3, 4. Ooh, pretend. Pretend that looks like a right triangle. And that means the x and the y are 3 and 4, and you need to find the r value by doing your little distance formula or Pythagorean theorem problem. Fill in the r and then come up with your 6 trig functions. So remember that's going to be sine, cosine, tangent, cosecant, secant, and cotangent. And remember, if you end up with radicals, I want you to rationalize the denominator. Well, that's all those. The next section is the same, except this time they tell you what quadrant you land in, and they give you one clue, so you can actually draw your triangle using those clues. And that's how we're going to finish up that worksheet. So that is your lesson on 1.3. Good luck. You got a worksheet and a book assignment.